Yes, my talk is titled Solid in Laravel, Too Much or Not Enough. So my name is Etienne Obaseki. I'm a software engineer. I like to read and I like to learn stuff. Interestingly, I'm also a failed rapper. I read a tweet recently that most software engineers are failed musicians, so definitely applies to me. All right, so the solid principles, as made famous by Robert Martin, talk about loose coupling when we're building our applications. They talk about making sure that the stuff that we use is easy to refactor and easy to change. And it popularly says that your application should outlive the parts that it's built from. So for example, if you're using some library or some framework, your application should survive the death of that framework or library. But it can be a bit difficult to do, especially when the framework offers a lot of helpers, like Laravel does. So how do you adhere to the solid principles while using Laravel? Okay, so this is the overview of what I'm going to do. Okay, so recently I was reading a paper on cathedral building in Europe, in Milan, and they were talking about how the cathedral builders, even though they built the structures long ago and with arguably inferior tools to what we have today, they are still marvels of engineering. And our job as software craftsmen is to build applications that can live forever. Okay. Yeah, so the solid principles are a set of 5 foundational principles that help to keep software accurate, testable, refactorable, and maintainable. So following solid helps to make your application easier to test, makes it easier to know that it works, and makes it easier to extend or maintain in the future. Okay, so there are 5 solid principles, right? I'll just run through them quickly. So single responsibility, open closed, list-off substitution, integration, interface segregation, and dependency inversion. So single responsibility says that a unit of your application should be responsible for, or responsible to only one actor. Should be responsible to only one actor. There's a similar principle that says that a function should only do one thing, but that's not actually what single responsibility is about. Single responsibility means that if you have a, so by the way, all the solid principles work on classes, on high-level modules, right? So single responsibility means that if you have a class, that class should be responsible to one actor. So for example, if you have a payroll class, for example, that payroll class should only be responsible to one entity in the organization. So for example, say you're writing HR software and you have a payroll class. That payroll class should perhaps be only responsible to finance. The payroll class should not be responsible to both finance and HR. So for example, and the reason why it becomes apparent when you look at things like, so for example, say payroll needs to calculate the salary of the worker. And that same payroll class also calculates how many leave hours the worker has. And so it works perfectly, right, at first. But then finance decides that, we want to make a little change here on how this works. And so you make that change and everything should work as it should. But all of a sudden, HR is broken, even though you didn't touch anything that had to do with HR. So single responsibility helps to make sure that functionality that relates to one actor stays in one place so that when you make changes, it doesn't spiral and affect other people. The open-closed principle says that a class should be open to extension but closed to modification. The principle is basically saying that whenever you need to add new functionality, you should not be modifying existing code, but you should be writing new code for new functionality. I should also say that these solid principles we shouldn't treat them as laws, as it were, but more as helpful suggestions, because some of the time it's difficult to keep it pure, you know. Okay, so so that's that one. So list-off substitution, made famous by Barbara Liskov, says that objects with common interfaces should be interchangeable. So for example, you have an animal interface, right? And so in your animal interface, you inject it into, say, your controller, for example, and you say, you inject a particular concrete of that animal interface. So let's say you use a dog in your controller, right? And so you say dog.barks or whatever, right? And you now need to make something of some other animal. No, sorry, not dog.barks, dog.eats, for example, right? So you need to use some other animal, and you use, say, a fish. But both of them share the animal interface, right? So it says that if you switch between your dog and your fish, they should both work the same way to your controller. Your controller should, it should not be apparent that, something has changed, right? Okay, so interface segregation. Interface segregation is single responsibility, but for interfaces. So it says that an interface should not have methods, or somebody that uses an interface should not be forced to use methods that they don't need. So again, back to the animal example. So say you have an animal class, and you have like a method back there. So dogs bark, but fishes do not. But if you now use a fish that implements that interface, you would have to make the fish bark, but fishes don't bark. Okay. And dependency inversion basically talks about how abstractions should not rely on concretion. So basically, your interfaces should not rely on concrete classes, for example. Yeah, this is all a bit heavy, but the principles themselves, you can learn them more about them by like reading the books about them. So Robert Martin has like a series of great books on them, and I encourage everybody to like read them. Jeffrey Ray also has a course on it on Laracast as well, talking about solid in Laravel. All right. Yeah, so the question is, are frameworks anti-solid? In Christopher Wilson, another author I read, he says that we live and die by the framework, and he went on to give an example of how an application that he had built in, was that Zen 2, had to be completely rewritten because Zen 2 was dead, right? And it took like a lot of work. So they had put a lot of work into writing that first Zen version, and then they had to like scrap it all, start from scratch because Zen 2 was no more. And he was saying that you should always try and, even though you are using a framework, and the framework is nice, it has a lot of helpful features, you should always try and make sure that your application can outlive that. And so another question I like to ask myself sometimes is, will Laravel live forever? Is there ever going to come a day when Laravel is dead, till Oswald is no longer maintaining it, and we all have to switch to something else? Well, hopefully not. And yeah, so Matt Stoffer at Laracon 2019 was talking about why he thinks Laravel can live forever, because of the great community we have and how Laravel basically always keeps innovating and doing new things. But still, regardless of that, we should continue to try to improve our application so that even if Laravel dies, we can move on easily. Yeah, so the MVC pattern, model, views, controllers, the bedrock of what we do as Laravel developers. Is it perfect as it is, or is there a way to improve it? How can we improve MVC? MVC is great at the beginning, but as you continue to build out your application, you begin to see some problems with it. You begin to have what we call fat models or fat controllers, depending on your preference. So it's where like your logic continues to grow and grow and grow, and eventually your models become like these very huge classes of like thousands of lines, and it's very difficult to find anything or to know what does, or even to make changes. It's particularly important because you may not be the one maintaining an application forever. And that's always a problem. So for example, if a developer leaves and a new developer has to work on it, how long is it going to take for that developer to understand everything that you've written? You've written a very nice application, it works, but is it going to live forever? Or by the time a new developer comes, are they going to have to scrap it and start again? And I think that following solid principles helps to make sure that, because it's always nice when something that you've built can continue to be used. So applying solid principles. All right, so let's go. So solid in our models. So what's the first problem with MVC? Fat models, right? So we see that models are actually conflated. They are not just models. They are actually two things. They're both models and they're persistence layers. So a model is a representation of state of an entity in our application. So entities are what our business logic is about, right? So for example, you have say an e-commerce application, right? And you have a product. So that product has a state, right? The product has a name, the product has a price, it has a bunch of stuff. So that's state of the product. When you fetch it from the database, that state gets reflected. But in Laravel by default, the model and the repository is completed. So that same model that represents the state of your product also fetches it from the database. And that's a bit problematic if you ever decide, for example, like in the other talk that Boson was giving, if you ever decide that you want to switch out from Eloquent to use something else, right? So it becomes, the model that has all your logic becomes a bit difficult to change. So what's the solution? The solution is to split our model, as Laravel gives into us, into repositories, which is the persistence layer, and the actual model which represents our state. So you would have, for example, I have a product there, and so it's split into the repositories and the actual product model. In our controllers, We can think of controllers from the sort of exposed as a sort of a factory for HTTP responses. So the controller gets input from the user the request, processes it, does whatever it needs to do, and returns HTTP. That's really all it should do. Everything else should be delegated somewhere else. So for example, I have a controller method here that's supposed to get a list of all the products. Right? So it's what it does is that it enters the index, gets the products from the repository, and then returns it to the view. So as opposed to having inside the controller method fetching the products and doing all that, then it becomes very difficult if you ever need to, for example, fetch the products somewhere else. You have to repeat yourself with all that logic that is written inside that controller. Alright, and finally, views. This one is pretty basic. Views should be views. They should only be representation. You shouldn't have logic in your views. I forgot to say at the beginning, I'm unfortunately very opinionated, so don't really take what I'm saying as gospel, depending on your uses, of course. But for the most part, the views really shouldn't have logic. Because again, it becomes very difficult. So imagine that you're putting a view for displaying the product, and inside that view, you calculate the price, for example. And then you now have to show the product somewhere else. Then you're going to put that entire view wherever you get it. Like that logic, it has to be abstracted somewhere else. Password. Right. Yeah, so in conclusion, while building today's software, we must do so with an eye on tomorrow. We must stop and think about the applications that we are building and then make sure that they are scaling. Make sure that the next person who is going to come and work on it, or if the team grows, the people who are going to come and work on it can find it easy to work on what we do so that they don't have to scrap everything and start again. Yeah, so there's this quote I like from the pragmatic programmer by Andrew Hunt, and it talks about that same thing about the cathedral builders. It says that 100 years from now, our engineering may seem as archaic as the techniques used by medieval cathedral builders seem to today's civil engineers, while our craftsmanship is still strong. And so we must build applications that will make our craftsmanship better. That's all. Thank you very much.